After implementing authentication, a common need is to protect specific routes from guests. For example, a guest shouldn't be able to visit the user profile page. In View Router, to protect a route, we use navigation guards. Navigation guards can be global, as we define the before each guard in app.view to hide the contents of the page and start the progress bar. Navigation guards can also be defined in component or per route. In these lessons, we will learn about the navigation guards before we integrate them with Firebase. Let's begin with the in-component navigation guards. These guards work like the lifecycle hooks and come in handy when you need to access components data from within the guard. Let's see how we can use them in the profile page component. The available component guards are the Before Route Enter guard, the Before Route Update guard, and Before Route Leave. Navigation guards always accept two arguments. The To argument, which is the route that is being navigated to, and the From argument, which is the route that is being navigated away from. It's easy to guess when the Before Route Enter and Before Route Leave guards run. The Before Route Update is special though. It triggers when we are navigating from a route to another, where both render the same component. This happens, for example, when we are navigating from a thread to another thread, since both routes render the thread show component. To protect the profile page from guests, we could use the Before Route Enter guard and redirect the users to the home page if they are not authenticated. To do that, in here we can check if we have an authenticated user in the state. And if we don't, we'll redirect to the home route by returning the route named home from the route guard. Okay, the logic here is sound. However, in the Before Route Enter guard, we don't have access to the component instance as the component has not yet been created. So this .store will be undefined. To solve this, we can import the store. By doing this, we are importing the current store and not a new instance, so we can safely use it here or in any other file. Also, for now, I will comment out the contents of the profile page and display a heading instead to make our lives a little bit easier, since we haven't revived the profile page since implementing the Firestore. I'll also comment out the import and registration of these components, as ESLint will complain now that they are no longer being used in the template. Since the auth ID is initially set to null, when we try to visit /me, we should be redirected to the home page. And we are. Awesome. To test that it works properly for users, I will manually set the auth ID to something. In just a few lessons, we will make this work with the authenticated user from the Firebase authentication service. But because of the async nature of that, it becomes a little bit trickier, so I'll just hardcode it for now. Lastly, I will omit the ready event from the profile page. This time, we should see our heading when we visit the profile page. Great. Before we move on to the per route guards, I want to show you a common use case for before route leave. When creating a thread, if the user has written something in the form and clicks a link, then all those changes are lost. To prevent that, we can ask the user to confirm the navigation before leaving the page. To do that, we can use the Before Route Leave guard in the Thread Create page to show the confirmation. If the user confirms it, we will perform the navigation. Otherwise, we will abort it. To abort a navigation, we return false from the guard. Let's check it out in the browser. I will click Cancel, and we get the confirmation message. If we cancel the confirmation, we stay here. And if we confirm it, we are free to leave. That's nice. Though I find it frustrating to have to confirm the navigation when I haven't typed anything. To improve the user experience, we should check to see if the form has any changes made to it. In order to do that, we can add a watcher in the thread editor to keep an eye on the form data to see if it's changed from what it was initially. We do this by adding a watch property to the component options. And then we add a method named after the data that we want to watch. In this case, the form. And, actually, in our case, we need to define the form watcher as a property instead of a method. That way we can pass the deep option. The handler function here does the same thing the method we wrote just a second ago would have done. It's the function that runs whenever a change to the form data property is detected. The deep option here tells Vue that the method should run not just when a change occurs directly to the form data property, but also to any of its properties, that is, form.title and form.text. Inside the handler, I'll check if form.text and form.title are anything other than the originally passed title and text props. And if they are different, I'll emit an event called dirty. This is a common term used to indicate that a form has unsaved changes. In other words, a dirty form is a form with unsaved changes. I'll also add an else statement here to emit a clean event. Though this might be unnecessary for most situations, it does make it so if the user makes a change to, let's say, the title, but then backspaces those changes so the title is back to what it was originally, then the form will be considered clean again. Now, let's listen for those events in the Thread Create page and update a data property accordingly. And we'll need to actually create the data. I'll initialize it to false, as the form won't be dirty by default. Now, we can only show the confirm message before route leave if the form is dirty. This should do the trick. I will log in and create a new thread. If I click Cancel Now, after typing in some data, I get the confirmation window. But if I backspace things to the way they were originally and click Cancel, I don't get the confirmation window. Also, if I go directly to start a thread and then navigate away, I also don't get the confirmation window. This is nice. There's still one problem though. When I hit Publish, I still get the confirmation pop-up. This is because, in the Save method, we redirect the users to view the thread they just created. To fix that, I'll just omit the clean event from the thread editor save method, since, on save, the form should no longer ever be considered dirty. Back in the browser, I still get to confirm that I want to leave the page while I have unsaved changes. But this time, when I hit Publish, the thread is created, and I'm redirected to the thread page. As an exercise, you can implement the same feature for the thread edit page, since we've given the thread editor the responsibility of knowing when things are clean and dirty. It should be fairly straightforward. If you get stuck though, feel free to take a look at the solution in the source code of the video. In the next lesson, we will learn about per route navigation guards. In-component guards are very handy when we need to redirect or cancel a navigation based on the component's data or a child component's data. However, there is another way to define before enter guards, that is, by registering them per route. We can do that in the router file. Sometimes this is also known as middleware. To get started, I will implement the guard that we implemented in the previous lesson to protect the profile route from guests. I will cut the code from the profile page component. And while I'm here, I'll clean up these unused guards. Then I'll paste the code over in our routes file. I'll change the name of the function from before route enter to before enter. This makes sense, as the function is now defined on a route, and so the route part is inferred. And since we've already imported the store into the router file, we are good to go. Also, since the profile component doesn't need the store variable anymore, I'll remove the import statement. Now, if we change the auth ID back to null, and try to visit the profile page as a guest in the browser, we are redirected back to the home page. Cool. I'll just change the auth ID back. To me, it makes better sense to have auth-related guards in the router file so they are organized, and you don't have to open the component to see if it's protected or not. Even better, you can define auth-related guards using metafields that we'll talk about in the next lesson. My favorite use case for per route guards is what I call componentless routes. These are routes that don't use a component. Let me show you. At this point, we don't have a route to log out. So, in order to sign a user out, we dispatch the sign out action from the navbar. This is fine, but it'd be nice to have a route, like /logout, that will dispatch our action and redirect the user somewhere like the home page. Normally, to implement that, we would create a page component with an empty template, and we would do the job in the lifecycle hooks. Using per route guards, we don't need to do all of these things. Let's get to it. I will create a new route with a path of logout. I will give it a name of sign out to comply with the other route names. Then, using the before enter guard, I will dispatch the sign out action and redirect the user to the home page. Also, to make sure the sign out action is complete before redirecting, I will use async await to wait for the action to be finished. And that's it. Notice that we didn't have to specify a component here. Let's give it a shot in the browser. I will sign in, and then, instead of clicking the sign out button, I will visit /logout. And, as expected, I am signed out and redirected to the home page. Great. In the next lesson, we will dive into the global navigation guards and meta fields. On top of defining navigation guards in components and per route, we can define global navigation guards. We can register global before guards using routers before each method. In fact, we've already defined the before each global navigation guard in order to clean up our snapshots. Just like all the other navigation guards, we see that before each takes a callback function. In this case, that callback function will run before every route is visited. As you might expect, the callback function can also take the to and from arguments. Just to make what's happening more visible, I'll add a console log in here so that we can see each navigation. Now, in the browser, we see each navigation in the console. So, if you need to run some code before each navigation, this is the way to go. Since we have already used the global navigation guard to unsubscribe from all our snapshots, let's go a step further and introduce meta fields. Route meta fields let us add custom attributes to the routes. Using the meta, we store arbitrary information about the route and then take some action based on that information. Let me show you. I will add a meta attribute to the profile route, and I will call it requires auth. I will give it a value of true. It's worth noting the name of the property here is completely up to you. It could be requires auth, protected, skinny jeans, literally anything you want. I just chose requires auth as it makes the most sense for our use case. Not only that, but the metadata can pertain to any type of data. It's not just for indicating that a page requires authentication. Maybe it has a piece of meta that describes the type of transition that should be used on a page. Or maybe it indicates that the page should smooth scroll on navigation, or navigate to the top, as we've already done in a previous lesson. I'll just remove this transition as it's not needed. Once we set the meta to the routes, we can check inside the global navigation guard if the route we are navigating to has a specific meta and act based on that. In our case, we can check to see if the route has the requires auth meta and make sure that the user is authenticated before we let him visit this page. In other words, we'll do exactly what we've done here in the before enter guard. I'll cut the before enter guard method here so that we can use it in our global navigation guard below. So, if the requires auth meta exists, we do what we were doing on the navigation route level guard a minute ago. I'll clean this up. Let's see if this worked. Let's make sure that the auth ID is set to null real quick. And check back in the browser. And yeah, we still get redirected to the home page. Great. You may think, what have we actually accomplished here? We have just moved the route guard around. However, now in order to protect another route, all we have to do is to add the corresponding meta instead of having to rewrite the route guard. If I add the meta to the category page, for example, we wouldn't be able to view it without logging in. It's hard to see it since we're already on the home page, but I'm getting redirected right back home. Let's just remove that, as it was only an example. Meta is also inherited by child routes. So, if the profile route had a child route called nested, let's say, it would also require that the user be logged in. In View 2, making this work would take a little extra effort, but in View 3, with ViewRouter 4, this is handled for us since the meta is a non-recursive merge of the child and parent meta. I'll demonstrate this by visiting /me/nested in the browser, and we're redirected back to the home page. Nice. Let's remove the nested route since we don't need it. In the next lesson, we will integrate our authentication system with the navigation guards and stop having to fiddle with the hard-coded auth ID in the store. While we have managed to apply a navigation guard and protect specific routes from guests, we haven't yet been able to integrate Firebase authentication with our route guards. The reason for that is that in our route guard, we need to check if there is an auth ID in the state. The thing here is that the auth ID is updated asynchronously. Specifically, the auth ID is initialized to null, and our Firebase observer updates it when the auth state changes. Thus, we need somehow to wait for the observer to trigger in order for us to know if a user is authenticated. If the authentication was initialized through an AJAX call, we would perform the call here by most likely dispatching an action. And then we would proceed with the navigation when the promise was resolved. Like this, we need to implement a way to know when the Firebase state observer has been triggered, and then proceed with the navigation. Let's take a look at our observer. The callback will run whether there's an authenticated user or not. So, if we wrap this in a promise, we can resolve it when the callback runs for the first time. To get started, I will create an action, init authentication, and I will place our observer inside. We'll also need to replace the instances of the store variable with this. Now, if we return a promise from our action, we can resolve the user coming from Firebase. Notice here that even though we resolve the promise, the observer will continue to run in the background unless we turn it off. I will add a console log to know when the callback runs. Now, let's dispatch the init authentication action inside of our global navigation guard, waiting for it to complete before doing anything else. And I'll just make sure our main.js file is saved. Okay, let's check it out in the browser. When we visit the home page, it works. And we see the console log. Now, let's try to log in and visit the profile page. This works as expected. While this approach seems to be fine, there is a significant issue. I will sign out to show you. Notice now that our console log is printed out 4 times, one for each page we visited. This means that every time we visit a page, we create a new observer. To solve that, we need to turn off the current observer before we create a new one. There is one way to turn off the auth state observer, and this is by using the unsubscribe function that is returned when we initialize the observer. This behaves much like the unsubscribe from onSnapshot functions that we've already seen. Once we get the unsubscribe, all we have to do is to call the function, and the observer will go off. So, we can store this function in the state and call it before setting up a new observer. For that, I will add an auth observer unsubscribe state property. And create a mutation to set it. Now, we can set the unsubscribe function to the state right after initializing our observer. Now, before we set up the observer, we can check if there is an observer already listening, and if so, we will unsubscribe from it. If we check it out in the browser again, our route guard still works as expected. And this time, there is only one observer listening. We can confirm that by checking the console messages when the user changes. In other words, when we sign in or out. Great, now it only logs once. Let's make one small improvement before we jump into the next lesson. In the init authentication action, we resolve the promise immediately when the auth state changes. This is not wrong, but it's a good practice to wait for the authenticated user to be fetched from our database before we resolve the navigation, so that we know that we always have the user in the page components. So, I'll make our callback async and await for the fetch auth user action to finish. And only after that resolve the user. Otherwise, we'll just resolve null. And actually, I noticed a flaw in our fetch auth user action. Here, we should make the action async so that it returns a promise, and then await for fetch item to finish. Now, we can be sure that before showing the page, the full user info is available. Though we've nailed down some great functionality in this lesson, I know it was a lot to follow. If you have any questions, feel free to leave questions or comments in the comments section below. In the last lesson, we saw how we can wait for async data to resolve in the global before each navigation guard. This is not limited to the global navigation guard, however. It can be done in any type of navigation guard. And it turns out this is the perfect solution for the before enter route guard we have commented out on the thread show route. The purpose of this route guard was to check if a thread existed or not before showing the thread show page, and if it didn't, redirecting to the 404 page. However, since we're not loading the thread from the Firestore until the page component is created, this was no longer working. So, all we should have to do now is uncomment the route guard, make it async, and fetch the thread from the Firestore before continuing on with the logic that was there previously. We'll also need to switch out the source data here for the store's state. Nice. Let's see what that looks like. Okay, it's still broken. I'll show you what's going on here. Let's console log what thread exists is returning. We're getting back an object with the ID of not exist. So what this is telling me is that there's an issue with the fetch item action. It is resolving with an object that is not the thread when the thread doesn't exist. We've yet to attempt to fetch an item that didn't exist yet, though, so we haven't caught this up until this point. Let's fix that. In the fetch item action, we can use the special .exist property on the Firestore document to see if the returned object actually exists or not. If it does, then we'll proceed just as we have been. Otherwise, we'll resolve null, as in the document was not found, so it's null. Now, back in the browser, our not found page is back in service. Awesome. Let's remove our console log. And while we're at it, we can clean up the last remnant of our static data in the import at the top of the routes file. Now that we've completed our route guards, or middleware, let's finalize which routes should be protected. To begin with, we want to hide the profile settings page from guests. So, I will simply append the requires auth meta field to the profile edit route. Next, we can prevent guests from creating and editing threads. Thus, let's append our meta to the thread create and thread edit routes. While this prevents guests from accessing the thread create and thread edit pages, it's all client side. There is nothing really stopping the request from being made directly to the Firestore database for creating or editing a thread. For example, if you open up the app JavaScript bundle and look through it, you can find the Firestore API key, the auth domain, and everything else you need to make requests directly to our Firestore instance. Anyone could come in here and copy the values and use them, just like we do in our project. Thus, we need to set up some rules on the server side, that is, in the Firestore itself, to decide whether or not someone has access to modify a thread or post. While we won't dive too deeply into the Firestore rules, let's just quickly take a look at the basics of how we might secure the threads and posts on the server side. Firestore has some great documentation to help us out with this. I'll leave a link in the description below to these docs so that you can dive in deep yourself if you want to. If we visit the Firestore database in the Firebase console, you'll see this link called Rules. The only rule that we have registered right now is the one that Firebase set up for us when we created the database. It's essentially a development free pass that says you can read and write to the database any way you want to until this date. Let's add a rule targeting how the threads can be read and written. You can target a collection using the match keyword and using this file structure like syntax. The word thread here in curly braces is like a variable that says, do these rules when trying to access any thread document inside the threads collection. Next, we can specify what we want to allow and on what condition. I'll start with reading. Since everyone can read our threads, our condition here is easy. It's just always true. Cool. Well, what about writing? This is where the functions are a little bit more important. Let's code that out a little bit with some imaginary functions. First, any logged in user should be able to create a new thread. We can write that something like this. If the user is logged in and the thread is new, then allow writing. The other scenario where a user should be able to write a thread is when they are editing their own threads. We could probably also enable moderators to edit threads, but we won't worry about that right now. So, the condition now looks something like this. Allow write if the user is logged in and is creating a new thread, or if the thread they are wanting to write to belongs to them. Nice. So what's cool about this is that Firestore actually supports defining functions inside of our rules, so we can actually make these functions work. We can do this just above the allow rules using the function keyword. In order to tell if the user is logged in, Firebase exposes a request object to all of our rules. Also, if the user is logged in, the request object will have an auth property that will contain the user from the Firebase authentication service. So, we can write our function like this. Next, let's work out the isNewThread function. Besides the request object, Firebase also exposes a resource object. This variable refers to the document you're attempting to write to. In the case that the document doesn't already exist, the resource will be null. So, we can write our function like this. Now that we're aware of both the resource and request variables, our last function is fairly straightforward. We can check for the ID of the authenticated user on request.auth.uid and compare it to the user ID on the thread. In order to get to the data on the thread, you must look under the nested.data property. Nice. That takes care of threads. But if you remember, creating a new thread actually also creates a new post. That is, the first post in the thread. So, let's make the same rules for posts. And, instead of duplicating the functions, we can dry up our code by making the function names more generic and pulling them up above both matches. Nice. That's cleaner. Now, we need to alter the rule that Firebase gave us by default to only allow reading of everything and not writing. This is because rules in Firebase look for any passing rule. So even if our thread and post specific rules prevented writing to a particular resource, this more generic rule would allow it. We'll also remove the time frame now and just always allow reading of all the data. This also means that we can remove the individual reads from the posts and threads. There's also one more thing we need to account for when creating new threads and posts. Creating a new post appends a post ID to its parent thread and the user ID as a contributor. Also, creating a thread appends the thread ID to its parent forum. This is getting a little too deep into the woods of Firestore, so I won't explain in depth. But essentially, we need to allow users to update only the posts and contributors properties of a thread that isn't theirs. And a user should only be able to append a thread ID to a form's thread property. While these two rules prevent an unauthorized user from setting any field other than posts and contributors on the thread, or any other field than threads on the forum, the rules do not prevent any user from setting invalid data to either of these. For instance, a malicious user could push a post ID to a thread that the post doesn't actually belong to and make it look like a user commented on a thread that he or she never did. However, I don't want to dwell on these rules for too long, so this will suffice for now. Perhaps with the Firestore rules documentation in hand, you can figure out a good solution for this yourself. Also, remember that these rules depend on the business logic and what permission you or the product team decide to allow users to have, and what actions should be allowed. With the rule definitions we've covered in this lesson, and the guidance of the Firestore documentation, you can define any business logic you need for your own applications. Finally, while we're here, we'll make it so that anybody can register as a new user. But an existing user can only update themselves. Sweet, that should do it for securing our database on the server side. While we're allowing reading of everything, there is nothing in the database that isn't public already. Any of the user's private data is in the auth service itself. Should you want to store any private data in the Firestore, in the future, you definitely have to adjust these rules. Let's copy and paste the rules from the console and save them into our Firestore rules file so that we can keep track of them in version control, and so they're accurate if we ever run Firebase deploy in the future. Awesome. Now let's try it out in the browser. In order to show that attempting to create a thread as a guest user doesn't stick, I'll comment out our route meta. Then I'll make sure I'm logged out and try to create a new thread as a guest. When I do, you see I get this Firebase error in the console. And if I go back to the forum, the thread doesn't exist. Perfect. Now, if I reinstate the route meta, I can't get to the thread create page at all. Let's also log in and try to edit a thread that's not our own, just to show those Firestore rules working. While the user experience here isn't necessarily great, our rules are working and we can improve the user experience later. Let's summarize what we've learned in this lesson. Route guards are great for preventing user access to certain pages in single-page applications. But we must remember that the route guards all happen on the client side. They primarily exist for user experience. We must still protect our data on the server side, in our case with the Firestore rules. In the next lesson, we'll protect some pages from logged in users for the sake of user experience. In the last lesson, we took steps to hide pages that only logged in users should see from guests. Another thing we should consider is hiding some pages from authenticated users that don't make sense for them to see. For instance, users shouldn't be able to visit the login and the register pages. I will add a new meta field to these routes that I will call requires guest. Let's implement this requires guest middleware. Inside the global navigation guard, I will add a new check for the requires guest meta. In this case, if there is a user, we will redirect the user to the home page. Also, since we are here, I want to make the requires auth middleware redirect to the sign-in page instead of the home page, since really that makes more sense. Cool. I think we're good to go. Let's test out all our middleware in the browser. I am a guest, and I will try to create a thread. As expected, I am redirected to the sign-in page. Let's try to edit a thread. Just so you know, later on, we will hide the Create Edit Thread buttons from users that are not allowed to perform these actions, because the flow right now is a little weird. Next up, I will sign in and I will try to create a thread. Nice, it works as expected. I'll edit the thread. Cool, also works. And let's try to visit the sign in page. Nice, I'm redirected to the home page. The same happens when I try to visit register. In the next lesson, we will improve the user experience regarding the redirects. I can't stand it on a website when I'm required to log in to proceed, but then I'm redirected to a random page, like the home page. What I expect to happen is, for example, when I click Start a Thread, to be redirected to the Create Thread page after logging in. We have a few different options on how to implement that. In our middleware, we can pass the route the guest is trying to visit to the sign-in component as a prop. I want to show you another way though, and this is to use a route's query parameters. Query parameters are the text you see in the URL specified after the question mark. For example, in question mark day equals Monday, the query param is the day and the value is Monday. If there are multiple query params, they are separated with an ampersand. In the middleware, where we specify the sign-in route, we can append query parameters using the query property. So, in order for the sign-in component to know where to redirect to after the user is logged in, we can set a query parameter, let's say redirect to the path the user tried to visit, which we have in the to argument. Let me show you how this looks in the browser. If I go to a forum as a guest and click Start a Thread, you can see that I'm redirected to the sign-in page, and the query parameter redirect to is set to the thread create path. Okay, this is cool. Let's tell the sign-in component to use the query parameter. I will create a method called success redirect. Here, I will create a variable, redirect to, that will have the value of the query parameter, which we can access under this $route.query, and then the name of the parameter. Be careful here not to confuse the $route with $router. The $route is the active route, while the $router is the global router instance. If the query param is not defined, I will set the value of redirect to a default path, which will be the home page. Next, all we have to do is to redirect to the desired path using router.push. Cool. Now I will replace the lines where we used to send the users to the home page with a call to our new method. That's in Sign In with Google, and here in our regular sign in method. Okay, let's give it a shot in the browser. I will try to create a thread as a guest. I will log in, and This time, I am redirected back to where I wanted to be. Awesome. If I log out and visit the sign in page, when I sign in, I'm redirected to the home page since the query param is not set. This feature is not something huge, but I believe it's a great improvement to the user experience. In the next lesson, we will improve the user experience for the post-related actions from guests to work better for the Firestore rules we made earlier. In the previous lessons, we protected the thread create and edit pages from guests, though we still show the thread edit button and the post editor inside the threads. Even though the Firestore rules don't allow guests to do either. So, in the thread page, we can use the auth user getter and conditionally render the post editor. If the user is not authenticated, we can display a helpful message, intriguing the user to either sign in or register in order to post a reply. Here, we can also pass the redirect to query parameter to help the user find the thread after logging in. We can access the active path under $route.path. And I'll do the same for register. Let's give it a shot in the browser. While I'm logged out, I see our message. And if I sign in, I'm redirected back to the thread, and everything works like it did before. Cool. While we're here, let's also hide the Edit Thread button for users who didn't create the thread. I used optional chaining here for when the auth user is null in order to quickly handle guests. Let's see what this looks like. When I visit a thread that's not mine, I don't see the button. But when I visit my own thread, the button is visible. If I log out, the button disappears in front of our very eyes. Very nice. In the next lesson, we will fix the authenticated user's profile page. A few lessons ago, we commented out the contents of the profile page so that we can more easily work with the navigation guards. I will revert that now and get our profile page working again, since we've left it broken since moving our data to the Firestore. To begin with, let's see what we get in the browser. The page works, since the authenticated user is fetched in the navigation guard before the page is rendered. That's good, but we don't see any posts or threads. And the sidebar here on the left is a little narrow and funky looking. Not sure what's happened there, but we can fix it real quick. Nice, that's much better. Now, the more important issue. Why don't we see posts or threads? Oh, of course we don't, since our Vuex store is empty. So, let's review what our component needs. The post list component is passed user.posts. And user.posts is a getter that looks for all the posts in the state with a matching user ID. Other than that, we don't need any more data to get the posts working. Okay, so what we have to do is to fetch the user's posts before we emit the ready event. However, we can't use the fetch posts action as it expects a list of post IDs to fetch. And we aren't storing the post IDs on the user, but only the user ID on the posts. Thus, we need to be able to query the post collection for all the posts where the user ID matches the current user ID. We can do that by targeting the post's Firestore collection and adding a where clause. Let's create an action that does this. I'll call it fetch auth users posts. Then I'll target the posts collection and call .where. Where takes 3 arguments. The first is the field you want to make your comparison to. We want to use user ID. The second is an operator. Should the field equal some value, be greater than some value, not equal some value, and so on? We'll say that it should be equal to the third argument. And the third argument is the auth ID. Now, we'll call the get method to execute the query. Unlike the Firestore onSnapshot method, get only executes once and does not listen for updates, but that's fine for our current use case. That also means we don't have to do any unsubscribing to the snapshot events. Now we can await for the results and loop over each of them to set them to the state. Sweet, that should do it. Let's go dispatch it in the profile page's created hook and wait for it to finish before emitting ready. Let's see if that did the trick. Nice. Now we have the user's posts. Even though we emit the ready event directly when there is no asynchronous calls in the created hook of a page component, we have created a mixin that handles that for components that need asynchronous data, like our profile page does now. So let's import and use our mixin. Now, in the created hook, we can call the fetched method when all the calls are done. Yep, still good to go. In the next lesson, we will work on the edit profile page and learn a cool router trick. In this lesson, our task is to fix the profile edit page. If we try to do that, we will face an issue that I'd like to explain first. The created hook triggers when a component is created, right? But when is a component created? When we visit the thread page, for example, the thread show page component is created. But what happens if we navigate to another thread directly? Since there is no way to navigate to another thread, I will add a link to a random thread on top to show you. And I will add a console log in the components created hook. When I visit a thread, we can see the message in the console. Now, if I click the link for the random thread, I am redirected to the thread, and besides the page not working, the created message doesn't appear in the console. This is because the thread show component is created the first time we visit the thread, and when I click the link, View Router switches the props and the URL, but the component is not remade from scratch. Because of this, the created hook is not run again, and thus the application breaks because we rely on the created hook to fetch the necessary data. To force View Router to destroy the page component when we navigate away, and thus create a new instance on every page view, there is a neat trick. We can pass a key to the router view component that will always be unique. This unique key can be the path of the active route. The router view component renders the matched component for the given path. So in our example, router view will be the thread show component. By passing this unique key, we force View to destroy the current component and render a new instance every time the path changes. This is the default behavior when navigating to a route that uses a different component. So, by passing a key, we actually apply the same behavior to routes that use the same component. If we try the same steps again, this time the second thread works fine, and we also get to see that the component is created in the console. Make sure you refresh the page before you try this, since if you've visited the thread page once, the thread has already been fetched and stored in Vuex, so the second page might work just fine because it already has the data. I will clean up the thread show page component before we start with the edit profile page. Since we have added the key to the router view, we can now navigate to our profile and then edit it without any issues. If we hadn't have added the key, we would have faced a bug since both routes use the page profile component. If we try to make updates to the form, however, our changes don't stick. This is because we haven't saved the user data to the Firestore. Let's update the update user action to save the data to the Firestore. Here, we receive an object, which is the whole user object. It includes all the attributes, like posts and threads, that shouldn't be editable directly. So, I will create a new object with the data that we want to let the users update. And because Firestore doesn't like undefined values, and some of these could possibly be undefined, let's make each one null if not provided. Next, we'll get the Firestore document ref. And this time, since we're only updating one document, we don't have to create a batch. Instead, we just call update directly on the ref and pass it the values that we want to update. That should do it. Let's check it out in the browser. Whoops, we forgot to make our action asynchronous. All right, I'll make an update. And we see that it's stuck. When I refresh the page, it's still there. Great, our data is persisting. In the next lesson, we will modularize the store since it has started to get a little hard to maintain.